This is half past paper week 17 for the higher tier. So all the odd numbers this week, and we've got 43 marks to do all together. These are all the topics that we're going to go through this week, half a past paper roughly, and those are all the Sparks codes if you have access to Sparks and you want to look up more of those questions. Here we go. Question number 1. Simplify n cubed times n to the power of 5. Now when we times, we add the powers. This is n times 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 n. So altogether, n to the power of 8. For question part B, we're dividing, so we're going to take away the powers. If you've got c cubed divided by c squared, we're going to do 3 take away 2, which is 1. So it's going to be c to the power of 1, which we just write as a c. If you do put the power of 1, that's absolutely fine. You're not going to lose any marks for that. And we also need to do d to the power of 4 divided by d. Now remember, if it's just a d on its own, it's the same as d to the power of 1, and 4 take away 1 is 3. So this is c and then d cubed, because I've got 4 take away 1 for the d. That cubed is only affecting that. If I wanted to cube everything, I'd have to write it like that. So that's absolutely fine. C, d cubed, like that is absolutely fine. Part C, and we're solving an inequality. Now remember, what we do to one side, we're going to do to the other. I like to put a dotted line where either the equals or the inequality symbol is. First thing we're going to do to both sides is get rid of this fraction. The fact that it's dividing by 2 is a little bit annoying, so let's get rid of that. And we're going to do that by timesing both sides by 2. We're always doing the inverse operation. Now that gets rid of that on the left, so we're just left with 5x. And on the right hand side, it becomes 14. Now 5 lots of x is bigger than 14. So what about getting that x on its own? And we're going to do that by dividing both sides by 5. So x is greater than, now don't forget you've got a calculator here, so you can just use your calculator, and 14 divided by 5 is 2.8. Now you're absolutely fine to write it as 14 over 5 if you want to, or you can write it as x is greater than 2.8, but either of those is absolutely fine. Don't forget to put this bit on the answer line as well, because it's really important to say if it's bigger than that or smaller than that or whatever it is, but in this case x is bigger than 2.8. Question number 25. A number m is rounded to 1 decimal place. The result is 9.4. Complete the error interval. So an error interval is just saying what is the biggest and the smallest it could have been for it to have rounded to 9.4. Now the smallest it could have been, remember it didn't round to 9.3, didn't round to 9.2, so the smallest it could have been is 9.35. Anything smaller than that and it would have rounded down to 9.3 or down to whatever it was closest to. 9.36, 9.37, that all rounds to 9.4, so that's good. The biggest it could be is 9.4999999. So what we do is we just say 9.45, and then see here this symbol doesn't have an equal to, so it can't actually equal it, but we can go up to it, and that's why we say it can go up to 9.45. So we rounded to the nearest 1 decimal place. It was the nearest 0.1. You always half that number, and so that's 0.05 above and 0.05 below, and that's why we popped that there and that there. Good, so that's the smallest and the biggest it could have been to round to 9.4. Question number 27. Amanda has 2 fair 3-sided spinners. Amanda spins each spinner once. Complete the probability tree diagram. So with spinner A, that's this one here, what's the probability of landing on a 2? Well, looking at spinner A, that's 1 section out of 3. The probability of not landing on a 2 are the other 2 sections out of 3. For spinner B, and we've got to do spinner B for here and spinner B for here. That doesn't mean we're spinning it twice. It just means that if we come up this pathway, we're going to spin spinner B, and if we come down this pathway, we're going to spin spinner B. So it's just having somewhere to put the options. So spinner B, what's the chance of landing on a 2? Again, just 1 out of 3. And not landing on a 2 would be 2 out of 3. 1 out of 3 is your chance of landing on a 2, and 2 out of 3 is your chance of not landing on a 2. Part B says work out the probability that spinner A lands on a 2 and spinner B does not land on a 2. So what pathway is that? We've got 4 pathways here. Either spinner A lands on a 2 and spinner B lands on a 2, or spinner A lands on a 2 and spinner B doesn't, or spinner A doesn't land on a 2 and spinner B does, or neither of them land on a 2. Those are the 4 different pathways. They're asking us, what if spinner A lands on a 2, so we want to go up this pathway, and then spinner B doesn't. So if that's the pathway you want, you times along the branches. If you wanted more than one pathway, you'd add the answers together at the end, but we always times along the branches. So 1 over 3 times 2 over 3, and remember, multiplying fractions, we're just going to do the top times the top, and the bottom times the bottom, so that's going to be 2 over 9 as your final answer. If it did simplify, you wouldn't need to simplify it. It doesn't say give your answer in its simplest form, and probability, we don't really care about simplifying it. That's all good. Question number 7. There is a total of 45 boys and girls in a choir. The mean age of the 18 boys is 16.2 years, and the mean age of the 27 girls is 16.7 years. Calculate the mean age of all 45 boys and girls. So they've already worked out the mean, which means they added it all together and divided by how many there are. So we know that the total age of all the boys divided by 18 is 16.2. So let's just work backwards here. And I'm going to do 16.2 times by 18, and that's going to give me 291.6. Same for the girls. The total divided by 27 is equal to 16.7. So let's work backwards here, and we would say that if I'm timesing by 27, 16.7 times by 27 is 450.9. That must be the missing value. Now if we add that together, we're going to get the total. So 291.6 add 450.9, that's going to be the total of all of the ages of all of the students. So add on 291.6, and then what we want to do is take that total, which is 742.5, and divide it by 45, because that's how many people we asked altogether. So 742.5 divided by 45, typing that in my calculator, is 16.5. There we go, and that would be the average age of all of the boys and all of the girls. Notice it's slightly closer to the girls because there were more of them, so it's going to skew it more in that direction. Question number 9. The diagram shows a prism. The cross-section of the prism has exactly one line of symmetry. So the cross-section is just that shape that you see the whole way through the prism. So if you sliced it like birthday cake, you'd see that shape the whole way through. So they're saying that that has one line of symmetry, and we can see that that would be going down the middle like that. So it's symmetrical, it's the same on both sides. Work out the volume of the prism. Now, volume of a prism is the area of that cross-section times by its length, which in this case is going to be 20. So our first job here is to work out the area of that cross-section. And that cross-section is that kind of house shape that you see. So we've got that rectangular bit, and then we've got the triangle on the top. Now the area of the rectangle isn't too bad. We've just got to do 10, which is the base, times 12, which is the height. So 10 times 12 is 120 centimetres squared. That would be the area of that bit. Now to work out the area of the triangle, we need to do base times height divided by 2. I know the base is 10, but I don't know what the height is, but I do know that this is 40 degrees. Now the fact that they've told me there's a line of symmetry is a good clue that we're going to need to split this into a triangle. And we're actually going to do SOHCAHTOA here. So let's just draw 1/2 of that triangle. What I need to work out the area is the height. So I'm going to put an X there. I know that this is 5 centimetres because I only want to go from the edge to the middle, which would be 5. It's 10 all the way across. And I know that this is 40 degrees. So what we're going to do now is label our sides. This side is the hypotenuse. It's over from the right angle. Imagine you're stood here. This side is your opposite, and this side is your adjacent. That's next to you. Now, in this case, what's involved? Well, we want to know the opposite, so that's definitely involved. And the adjacent is helpful information, so that's definitely involved. I don't know how long the hypotenuse is, and I don't want to know it, so that's all good. Okay, so now we need to think, is it going to be SO? Is it going to be CA? Or is it going to be TOA? Now, O and A being involved, we're going to use TOA. Cover up the thing you want to know, which is the opposite, and do the sum that's left behind. So this is going to be tan 40. Remember, if you're using SO, it would be sine 40. If you're using CA, it would be cos 40. But because we're using TOA, it's going to be tan 40. and we're timesing that by the adjacent, so tan 40 times by 5. Typing that in my calculator, tan 40 times by 5 is 4.195498156. Now remember, don't round anything until you've got to the end of your answer. So I'm going to keep that there. That is the height. So I know that that length there is this height here up to the top of the triangle. So I now want to do base times height divided by 2. Now you could do 5 times that number divided by 2 and then double it to take into consideration both halves of the triangle. I'm just going to treat it as one big triangle. So I'm going to do 10 times by that answer of 4.19 blah blah blah, and then half it because it's a triangle, so always for the area we need to divide by 2. Now I've not cleared it from my calculator, so I'm going to times that answer I just got by 10 and then divide that by 2, and that gives an area of, let's put it up here, 20.977497, which I then want to add to the 120 to get a total area of that whole cross section. So let's add 120 to that, and that gives me 140.977. So down here, 140.977, that's the area of the cross section, and then we need to times that by how far back it goes, which we said was 20, the length of the shape. So times that by 20, that's going to be 2,819.549. What are we rounding to here? It says 3 significant figures. So there's your first significant figure, there's your second, there's your third, but the 9 rounds up. So this is going to be 2,820 centimetres cubed to 3 significant figures. 5 marks for that one. Well done if you got that. Question number 11. The diagram shows a triangle P on a grid. Triangle P is rotated around 0, 0 to give triangle Q, and then that's translated to give triangle R. Describe fully the single transformation. Well, let's do it. Okay, if we're going to rotate this around the origin, what you'd want to do is put your hand up in that exam, which I know you're all terrified to do. Those invigilators, they're not that scary, you know. So you put your tracing paper over the top. You would then draw around P. Now, I think it's really helpful to draw around it, but put an arrow in it facing up. And then you're going to hold your pen on that point and spin the tracing paper round, okay? And by doing that until the arrow is facing downwards, because we want 180 degrees, we would then know where to draw the triangle. I've not got the luxury of tracing paper on this, so what I'm going to do is just map it out. So I know that point would go there, I know that point would go there, and I know that point would go there. So I'm looking at a triangle, that triangle being here, that's Q. That's where it would end up. And then we're going to translate it. So remember, the top number in a vector is left and right. Negative is left and positive is right. And the bottom number, positive is up and negative is down. So this is going to be 5 right because it's positive, and then 2 down because it's negative. Now, it doesn't matter which point you pick, but if you pick this point, you're going to that point on the new shape. So 1, 2, 3, 4, 5, 1, 2. That is now the top of my new shape. And you could do that with each coordinate, or you can just draw it from there, but remembering that you're going to the same point that you started from. So there we go, that's R. Now I'm being asked to describe fully the single transformation that takes P to R. So how would I get from P to R? And that is going to be a rotation still, but it's going to be around a different point. So here is where you'd get your tracing paper again. You'd put it on P and you'd try different coordinates until it landed on that. Now I can get this, because it's 180 degrees, it's actually quite a bit easier if I just use the coordinates. And there we go, we can see that this point here would be the centre of rotation if I spun that round. So I'm looking for a rotation, and that's going to be 180 degrees around the point. Now the coordinate of that is 2.5 minus 1. Okay, 2.5 minus 1 is the centre of rotation. Under the transformation that maps P onto R, so that transformation that we've just described there, the point A is invariant. Now if something varies, it changes. So if it's invariant, it's not going to vary. So it's not going to change. Write down the coordinates of point A. Now, you might be thinking, well, every single coordinate changes. This point goes down here, this point goes over here, And I would agree with you, but they're not necessarily talking about a point on the triangle. They're talking about a point somewhere on this graph. When you spin that tracing paper around, there's one point that doesn't move. This might feel a bit like a trick question, but it's actually this point here. Where your pen stays on that tracing paper, that point does not change. When you rotate it round, this point stays in exactly the same place. That's the invariant point, okay? So it might seem a bit tricky, but once you've done one of those, it then makes sense. So yeah, 2.5 minus 1 is the point that does not change. Question number 13, and we've got inequalities on a graph. So on the grid, show by shading the region that satisfies all of these inequalities. Now when we're doing this, we want to draw where it's equal to, and then we'll worry about which side to shade afterwards. So I want to draw all of these lines. Now, just before we start drawing as well, if you've got this or this, then that line is going to be dotted. If you've got this or this, if it's equal to as well, then that means you can include the line in the region, and we show that with a solid line. So before I begin, I'm making a quick note that all of these lines are going to be solid because they're all greater than or less than or equal to as well. So we want to include the line. Now I'm going to start by drawing the line x equals 0, which is also known as the y-axis. So that's the line x equals 0 there. And I also want to draw the line x equals 2. Now, I'm told from the inequalities that we want x to be bigger than 0 or equal to, and less than or equal to 2. Now, you always shade what you don't want. So I don't want anything on this side because that's less than 0. And I want x to be greater than or equal to 0. So I don't want any of that. Oh, can't have that going over. That would annoy me. And I also don't want anything on this side over here because that is when x is greater than 2. And I want x to be less than 2. So there we go. We know already that we're just looking at that strip there. Let's change colours for the next bit. So I've now got to draw the line y equals x add 3. Now that line we know has a y-intercept of 3 and a gradient of 1 because it would be 1x add 3. So I know it's going to cross at 3 and have a gradient of 1, which means I know it's going to look like that. So it's crossing at 3 on the y-axis, and every time you go across by 1, it's going up by 1. Now again, we need to shade what we don't want here. So let's shade, should we shade in green? Yeah, why not? Now I want y to be less than x add 3. What you can do is pick a point on one side of that green line. So the origin is always a good point to pick. If I pick the origin 0, 0, I can then substitute that in. Is 0 less than or equal to 0 add 3? So I'm using the point 0, 0 because it has an x coordinate of 0 and a y coordinate of 0. So then I can substitute that in. Is 0 less than or equal to 0 add 3? Yes, it is. So that point is good. And if that point is good, that means every single point on this side would be good, and every single point on the other side we don't want. So that means that I now know that I can shade this side of that green line. I don't want anything on that side. None of the coordinates on that side would satisfy the inequality. Last but not least, we're going to draw this line. 2x add 3y, well, we're going to draw this one, is equal to 6. Now, the easiest way to draw a line when both the x and y are on the same side is to use the cover-up method. If you want to know when it crosses the y-axis, you can make x equal 0. And making x equal 0 makes that term go to nothing. And then we know that 3y is 6, so we know it will cross at y equals 2 by solving that equation. Okay, equally, if I want to know when it crosses the x-axis, I can make y equal 0. And we know then it will cross at x equals 3 by solving that equation. So I know it will cross y at 2 and x at 3, which means it's going to cross here, and I know it's going to cross, oh no, wrong way around. I know it's going to cross here, and I know it's going to cross here. And that's going to make that line. As long as you've got 2 points, you therefore know the rest of the line. So we're going to look like, oh, that roughly. Yeah, done it. And then we want to shade, we want 2x add 3y to be greater than or equal to 6. Let's use that origin again. So 0, 0, if I was to substitute that point in, 2 lots of 0 add 3 lots of 0 Is that bigger than or equal to 6? No, it isn't. So I don't want the origin and I don't want anything else on that side. So we would shade that out, and therefore the region that we want with a capital R, label the region R, is that bit in the middle there that satisfies all of the inequalities. 4 marks for that one. Okay, part B, the diagram below shows the region S that satisfies the inequalities. So they've already done this for us. Jeffrey says the point with coordinates 2, 4 does not satisfy all the inequalities because it does not lie in the shaded region. Is Jeffrey correct? Well, the point 2, 4 is here. And it quite clearly lies on the line x add y is less than or equal to 6. And even if we substitute in those points, 2 add 4, that's your x coordinate, add your y coordinate, it is less than or equal to 6. So I think Jeffrey thinks that if it's on the line, it's no good. But because it's equal to, as well as being less than, it can be on the line. So we're going to say, no, it's a solid line less than or equal to, so it can be equal to as well. So it can lie on the line. Absolutely fine. Okay, question number 15. Prove algebraically that 0.73 recurring can be written as 11 over 15. So we start this by saying let x equal 0.733333 ... That's what that notation means. Now, if that's x, and I want to line these 3's up underneath, then it would be a good idea for me to get 10x, because I know that will be 7.33333. Now there's only one digit repeating here, so I only need to times by 10. If you had 2 digits repeating, like it was going 313131, then you'd times by 100 to line up the 3's under the 3's and the 1's under the 1's. But here you only need to times by 10. We're then going to subtract, but I'm going to do the bottom row, take away the top row. Now 3 take 3 would be gone. Everything from this point onwards would cancel out. 3 take 3, 3 take 3, 3 take 3 is all gone. But I need to do 7.3 take away 0.3, and I'm doing the bottom row take away the top row. I can't emphasise that enough. If you want to write it out the other way, you absolutely can, or if you want to write it above, you absolutely can. But 7.3 take away 0.7, and that's going to be 6.6. So 9x, because I'm doing 10x take away x, is 6.6, which is 7.3 take away 0.7. Okay, now that means that x, if I want to know what x is, which I do, because that's what we're trying to work out, I'm going to divide this side by 9, and I'm also going to divide this side by 9. So I've got 6.6 over 9. Now that's almost as a fraction, but I can't have a decimal point in the answer, so I'm going to make that 66 over 90 by timesing the top by 10 to get rid of that decimal, but also timesing the bottom by 10 to keep it equivalent. Now 66 over 90, they're both in the 6 times table, so I can simplify that to be 11 over 15, which is what they're looking for in the question, so we've done it. So there we go. That is recurring decimals to fraction, really common topic, so make sure you know how to do that one. Question number 17. The histogram gives information about the distances 80 competitors jumped in a long jump competition. Calculate an estimate for the mean. Okay, so normally when we do an estimate for the mean, we have this information in a table. So let's maybe try and do a quick table for this. So the categories, the class intervals, would be given by the width of the bar. So the first one's going to be 6.4 to 7.2, and I know the notation for that would be slightly better, but hopefully that makes sense. 7.2 to 7.6 is the next category, and then we've got 7.6 to 8.0, and then I've got 8.0 to 8.2. Now the frequency would normally be in this column, and then we'd do midpoint times frequency, we'd add it all up and divide by how many there were, or how many, what are we looking at, how many competitors there were, so divide it by 80 afterwards. Now, I don't know how many people there are, but I know that we get the frequency on a histogram by finding out the area of the bar. So how many people are in this category? Well, it would be the area of that category. And we can see that from 6.4 to 7.2, that has a width of 0.8. So 0.8 times by the height, which is 10, base times height, area of a rectangle, is going to be 8. So there's 8 people in that first category. In the next category, it's 0.4 wide and it's 50 tall. So I'm doing 0.4 times by 50, which is going to be 20, I think, 0.4 times 50, yeah, 20 for that one. Then for, let's write that in, 0.4 times by 50. For the third category, we're doing the width again, which is 0.4 times by the height, which is 100. So 0.4 times by 100 is going to be 40. I'm not doing the same format for any of this, am I? There we go. And then for that last category, it's just 0.2 wide and it has a height of 60. So I'm doing 0.2 times by 60, and that's going to be 12. So I've got 12 in that last category. Now, if I want to work out the mean, I'm going to do midpoint times frequency, midpoint times frequency. So I'm going to do the halfway point of this category here, halfway between 6.4 and 7.2. If you're ever not sure what the halfway point is, you can always add them together and then just divide by 2. It's almost like you're finding an average. So that's going to be 6.8. So I'm going to times that one by 6.8. For the next one, I'm going to times by 7.4. For the next one, I'm going to times by 7.8. And for the last one, I'm going to times by 8.1. So let's work out all of those. 8 times 6.8 is going to be 54.4. And then the next one, 20 times 7.4 is going to be 148. 40 times 7.8, that's going to be 312. And then 12 times 8.1, that's going to be 97.2. We'll then add all of those figures together. And that adds up to 611.6, but remember that would be the total. We're asked to find the mean here. Now, to work out the mean, we need to divide by how many people we asked all together, and if you add together the frequency, it's 80, but we can also see that we get that value in the question as well. So we're going to divide this by 80, divided by 80, and that gives us 7.645 meters. That would be our answer to that one. A very, very tricky question. We don't often see it in that format, but hopefully that makes sense for 4 marks. Okay, question number 19. ABCDEF is a regular hexagon with sides of length x. Now, before I start this question, I'm going to say this is exceptionally difficult, very much a grade 9 question. So strap in, it's a tricky one, but doable, okay? So just bear with me. Now, we've got a regular hexagon with side lengths x, so let's draw that in. I've got x here, x here, x here, x here, and so on. And then the hexagon is enlarged, scale factor f by scale factor, centre f by scale factor p to give the bigger hexagon. So the linear scale factor is p, so it's p times bigger. And then we're talking about areas, so it might be helpful to just state here that the area scale factor, if your lines are 2 times bigger, then your area is 4 times bigger. If your lines are 3 times bigger, then your area is 9 times bigger. So if the linear scale factor is p, then the area would be p squared times bigger because it's a 2-dimensional thing. So show that the area of the shaded region in the diagram is given by this. Now, don't be scared by that. It seems very overwhelming, but we're just going to break it down. I don't know how to work out the area of a hexagon, but I do know how to work out the area of triangles. So I'm going to start by splitting this shape up into 6 equilateral triangles. Now I know they're equilateral because it's a regular hexagon, so it's going to be the same in all directions. So that means this is x, and if it's an equilateral triangle, I know that this is 60 degrees. So the area of each of these triangles is going to be given by half AB sine C, which is half times x times sine 60. Okay, so sine 60 is root 3 over 2. And that's one of the exact values you're expected to know, but you do have your calculator, so you can always type that in. So each of those triangles is half x squared times root 3 over 2. But we have 6 of them to make up that hexagon. So I'm going to times that by 6, and a half times by 6 is 3. So I'm going to take the half, times it with the 6, and just turn that into 3. So that's 3x squared times root 3 over 2. Okay, that is the area of the hexagon A, B, C, D, E, F. That's that regular hexagon. Now, if I want the area of the bigger shape, I know I can take that here and times it by p squared. That would get me to the bigger one. However, they want just the shaded bit. So we need to times it by p squared, but we also need to take off that. So therefore, overall, what we would say is the area of the big hexagon, let's do a terrible drawing, take away the area of the little hexagon, is going to give me that, I can't draw it, it's going to give me that bit. Oh, can I do it? Can I do it? I don't know. This bit, right? So if I have the big hexagon and take away that bit, I'm going to get the bit that's left. So this here is 3x squared times root 3 over 2, but we're going to times it by p squared because that's going to make the area bigger. Take away the original, which is 3x squared times root 3 over 2, and that will be the area. So we just need to cancel this down. I've not given myself enough room there at all because I did a silly drawing in the middle. There we go. Now, can we see that this actually is starting to look a little bit like this? Well, yes, we can. So we can factorise out any common factors. Both of these have 3 root 3 over 2. 3 root 3 over 2. So let's take that out the front, which is what they've done. 3 root 3 over 2. And then you'd be left with p squared x squared minus x squared. And if you chose to take that x squared out as well, and they've factorised it by putting it in front, we've got 3 root 3 over 2, p squared minus 1, x squared. And that's where it's come from. Very, very scary, very much grade 9. Hopefully that makes some sense. There's a lot of different skills at play there. So if you are aiming for a grade 9, yeah, definitely try and make sense of that question. But if not, don't worry too much. And then this last question, again, really, really challenging. These last, how many marks we got here? Last 5 marks, really difficult. Again, very much grade 9. Question number 21, I've got 5c add d equals c add 4d. Now let's write that out again because it might be a bit clearer. So we're going to try and get all of our c's on one side and all the d's on the other side so we can try and find the ratio. So taking c away from both sides and taking d away from both sides, I've got 4c is equal to 3d. Now, if you've got an equation with a c on one side and a d on the other side, if I wanted to make them the same, it's saying I would need to times c by 4 and I would need to times d by 3. Therefore, I know that d is bigger than c because I would need less of them to make the same answer, if that makes sense. If you know that 4c is equal to 3 lots of d, then you know that c to d is in the ratio 3 to 4. So you can almost switch it round. If you made d4 and you made c3, then both sides would be 12, and so that works. So they must be in that ratio. So the ratio they're looking for here is 3 to 4. Now, this last one, I'm going to take it all over to one side so I can factorise it. So 6x squared minus 7xy minus 20y squared. Now, I'm going to, and say that equals 0. I'm going to factorise this. I'm going to factorise it by splitting the middle. So I know that if I do a times c, 6 times 20, I get 120, which might be 1 times 120, or 2 times 60, or 3 times 40, or 4 times 30, or 5 times 24, or 6 times 20, or 8 times 15, that'll do it. 8 times 15, I like the look of that. So 8 times 15 is 120, but I can make 7xy, I can make that using 8 and 15. So this is going to be 6x squared minus, let's do minus 15xy, add 8xy, that would make the minus 7xy, minus 20y squared equals 0. And then I'm going to factorise these two terms and factorise these two terms. This is splitting the middle, this factorising method. So these are both in the 3 times table and x. So I'm going to take 3x outside, and that would be 2x minus 5y. Add, and with these two, I've got 4y in common. And again, that leaves 2x minus 5y. So I can therefore say I've got 3x add 4y, lots of 2x minus 5y. Now we're told in the question that both x and y are positive for this. So I know that to solve this, either this needs to equal 0 or this needs to equal 0. So either 3x add 4y needs to equal 0, or 2x minus 5y needs to equal 0. And if 3x add 4y is 0, then 3x equals minus 4y, and we're going to have a negative there, so that's no good, that's not going to get me anywhere. However, if I add 5y to both sides, 2x equals 5y, and so everything's nice and positive here, that's all good. And so just like we did with part A, if I know that 2x's is equal to 5y's, then x to y, that ratio would be 5 to 2. And so 5 to 2 is the answer that we're looking for here for 3 marks. But again, very, very, very challenging. Grade 9, definitely at the end there. Those last 5 marks and 4 marks, those last 9 marks, really very much pushing to get those grade 9s. So well done if that made some sense and you were able to follow along, but don't worry if it didn't, okay? They're extremely challenging towards the end of the higher paper, and they're there just to really stretch and challenge. So have a go, but don't worry if it doesn't make sense, okay? Don't put that pressure on yourself. Let me know in the comments if you've got any questions at all. I'd be happy to help, and I look forward to seeing you guys next week for week 18.